Good morning, everyone. Welcome to the Module 1 Introduction to Crystals. As you can see here, the learning outcomes that are expected from this lecture is first, understand the concept of crystals. The second, be able to draw the 7 crystal system according to its lattice constants. The third, be able to draw the 14 Graphis lattice. Be able to calculate the number of atoms in a unit cell. The fifth, be able to calculate the atomic packing factor and coordination number of a unit cell. The sixth, understand the structures of ionic crystals. Be able to calculate the theoretical density of a particular unit cell and be able to determine the types of crystal and its lattice constants, density, and atomic diameter of widely used engineering materials. Just to remind you that you have to make an assignment, that you have to make your study note in handwriting. Yeah, so I hope this will help you to learn to study the subject and make notes. You can make it in a regular form like this. So just a simple what you have learned in pointers. Then for each topics that you learn, you note your comments, your ideas, or anything that you need to write in order for you to understand the whole subjects. The same thing can be also written in a mind map format. So it's just like your mind, and then you have a map in your mind that number one, the topic that you have learned is this, and it is about A and B, and the second is about this, the third is about this, and the fourth is about this. Please submit it in mass. To achieve the learning outcomes, so the outlines of this section is the first review on Introduction to Metals Engineering or PMT. What is a crystal? Type of crystalline solid, lattice, unit cell, the 7 crystal system, the 14 Barré lattices, atomic packing factor and coordination number, ionic crystals, which is ceramics, and theoretical density. Okay, now we move into the first section, the review on Introduction to Materials Engineering, or pengantar material teknik PMT. As you can see, you have learned about materials and packing. So for example, if we are talking about silica, silicon dioxide, or we also call it as silica. Silica comprise the most abundant materials in our earth crust. Yeah, it is like a sand. Yeah. So we have learned in PMT that the materials can be divided into two. The first is the crystalline materials, yeah, where the atoms packed in a periodic order in three-dimensional arrays, and usually the crystalline materials are metals, many ceramics, and some polymers can also crystalline materials. And the second is non-crystalline materials, or we call also amorphous materials. Amorphous materials doesn't have any periodic packing, yeah, so they are randomly ordered. Usually it is occurs for complex structures or rapid cooling or in polymers. So for example, silicon dioxide or silica, if it is crystalline, the atoms are structured in an ordered manner like this. Yeah. So the blue dots here is the oxygen, and the red one is the silicon. Yeah. So the shape or the real things that you find in daily life for silica is the glasses. Yeah, so the glasses is like this. Yeah, and if it is amorphous or non-crystalline silica, the arrangement of atom is not in an ordered manner like this. Yeah, so it is non-crystalline materials, and in real world we see as sandy silica. Okay, now we move into the second section about what is crystals. The first example of a crystalline materials is steel. For example here, the steel which is used in the London Bridge. If the steel used in the bridge is sort of cut, and then we see the microstructures under the optical microscope, the microstructure will look like this. It consists of two phases. The first one is the perlite. The perlite is this black one, stripy black one. like this, and also the ferrite. The ferrite is the soft face, the white one here. If the ferrite is looked under the high resolution transmission electron microscope, it will look like this under the high resolution transmission electron microscope. You can see one dot is one atom, and if we draw illustratively, it will look like this. Yeah, so atoms, atoms, and this periodic arrangement or order arrangement is called body center cubic, and this periodic arrangement is called crystals. So steel is crystals. The second example is the vertical fin of a plane. Yeah, it is made of aluminum. This one. Yeah, the again similar approach. If the aluminum is cut and then look under the optical microscope, this is how the microstructure look like. It's sort of like a single phase. Yeah, but it's not actually a single phase. If the grain is then enlarged in a transmission electron microscope, this is how it looks like. So aside from the matrix, we can also see some precipitate here. This is precipitate, it's called omega. Yeah, this omega precipitate, and this one is the theta prime precipitate. You can see that at the tip of the omega precipitate, there is a small particle. If we see the small particles under the high resolution transmission electron microscope, yeah, it will look like this. You can see, so this is the omega, and this is the small particle. Yeah. If we enlarge this area, so the interface between the omega and the matrix, it will look like this. And then if we focus on the matrix here, we can see again, we can see that it is consists of atoms, atoms, atoms in a regular array. And if we draw, it will look like this. But now the arrangement a bit different with the previous one with the steel. And this periodic arrangement is called FCC, phase center cubic. And it is crystals because it is ordered. So aluminium is the second example of crystals. So what is crystals? Crystal is a solid. Yeah? It must be solid. Yeah? Solid consisting of a three-dimensional periodic ordering of atoms, ions, or molecules. So liquid will never be a crystal. Yeah? This kind of solid is termed as crystalline solid, yeah, or padatan crystalline, while at the other hand, the solid which doesn't have a periodical ordering of atoms, we call it as amorphous solid, yeah, padatan amorph. Most metals, the aluminium, steel, copper, and their alloys are crystalline, while glass and most polymers, yeah, plastic, rubber are amorphous. There are two kinds of crystalline solids. The first is the single crystals, where in the material all atoms arrange themselves in one direction only one direction. While the polycrystals, this material consists of several groups of atoms of grain. Each grains have different orientation to each other. Let's This is the example of a single crystal. Yeah, the first one is the diamond single crystal for abrasive. The material, for example, is this the cutting wheel. This is to cut the roof tile. As you can see, the tip of the cutter is covered with diamond single crystals. Yeah, in a form of powder. Yeah, if we see the diamond, yeah, it is a single crystal for each diamond. The second example of single crystal is turbine blade. So this is the turbine of jet engine. So this is the blade. Yeah, there are many stages. So if we see a single blade, it will be look like this, and it is made of nickel superalloys. The microstructures is consists of many grains, but all grains are directed into one direction. Yeah, so we call the nickel superalloys turbine blades. It is a single crystal. Most engineering materials are polycrystals. One example is the niobium, hafnium, tungsten plate with an electron beam weld. So this is how the electron beam welding. It is joining two plates, yeah, and at the joint, yeah, there is a welding area. So here, the microstructure, this is the welding area. As you can see, each color, yeah, it consists of one grain, yeah, one grain, one crystal, yeah. So this yellow one is one crystal, the purple one is one crystal, and each grain, they are randomly oriented. So you can see in these materials, we have so many grain, and one grain is one crystal, so it is examples of polycrystal. The next example of polycrystal is the bullet case. Yeah, this is the bullet case from the brass cup. Yeah, and then it is extruded. It becomes long. Yeah, and it becomes the bullet case. If we see the microstructure, it is made of copper. Yeah, it has many grains. Yeah, so each grain or each butir in one grain atoms are oriented at the same direction. So this is one crystal, and because there are many crystals, there are many crystals, we call it polycrystals, and there are some twinning as well in the materials. Now we move to the section 3, which is the types of crystalline solid.